Hey, gang.
Hey, Lady.
Hey, everybody, and welcome to As Seen on Show and Tell, the Adafruit Show and Tell. We use every week at 7:30 p.m. Eastern Time on Wednesdays. It's a good time had by all. Hang out with your favorite crafters, makers, friends you didn't know you have, friends you do know you have, here on Google Hangouts. We're broadcasting live from the Adafruit Factory, but right now we're going to be watching some wonderful people show off their making, crafting, 3D printing, accessible technologies, resin, all sorts of good stuff. We're going to start off with some Adafruit peeps and then see who else is on the plate. Take 2-3 minutes, show your project, get out here at 7:50. Start off with Noe and Pedro. What are you printing this week?
Hey folks, so we're printing a couple of Lego adapters for the Cricket board and Circuit Playground. So we built a little faceplate. We talked about it a little bit last week, but this week we released a guide. So if you guys head on over to learn.adafruit.com, you can see the guide for this project. A couple of 3D models that we made for the various components, like the servos and the TT motors. And then you can use a bunch of different Lego pieces to create caster wheels and other mechanisms and things. So here it is in action. This is sort of the stripped down version, as simple as you can get it. Just the faceplate, a couple bricks, and 2 wheels. And then you can do something a little bit more extravagant. Maybe you can 3D print a little Adabot robot, kind of give him a little chair. So this is our kind of more beefed up version with a bunch of more Lego pieces. We, of course, made Adabot. He's 3D printed. We made him as a Lego scaled minifig a couple months ago. So I thought I'd put him up there. And he's just kind of waving. It's on top of a micro servo.
That's so cool.
It's a lot of fun. So it's all pre-programmed in MakeCode, Microsoft's MakeCode. And some of the lights just kind of light up. There's sound effects, but we're not playing through right now. But there are some sound effects and a lot of different things with it. Some sensing. But right now it's really kind of simple rover. So if folks got some spare Lego parts, definitely give this a shot. It's a lot of fun, especially since we had a bunch of spare Lego pieces. Kind of cool things together. All right. So that's what we have. And yeah, check out the guide for some parts.
Okay, we'll be showing the videos often more on Ask an Engineer.
Cool, thanks.
All right, thanks.
Okay, next up, JP.
Hey guys, so thanks for reminding me, because you just showed your awesome Lego stuff, and I love the rover you made. It reminds me, last week, or the week before, I was out on vacation last week. The week before, I had been working on a Cricket to Lego and solenoids to Lego thing. So I put together this one on the live stream last week. Let me fire it up. It's part of a little orchestra of solenoids, as you can hear them there, and I just have a control on the Circuit Playground Express to increase the tempo there of this one, but I was using it to tap on little glasses and metal objects and stuff to make music with. So I just stuck this one on with a base plate on with some double stick tape, so I'm really looking forward to 3D printing some much more proper mounting plates that the Ruiz brothers built. So thanks for creating those guys. And so for my next project, what I'm going to be working on for tomorrow, I have a couple things to show. It starts off with a Cricket and a Circuit Playground Express and a little micro servo. Let me turn this on. And I've written some code in CircuitPython that is essentially a loudness sensor on the microphone. So when I snap my fingers or yell at it, hey! You can see my little micro servo wiggles a little bit there. And the reason I'm doing this is for a slightly more elaborate project that we'll be building tomorrow on the show, which is Edvard Munch's The Scream. And so normally you look at this and you feel existential angst, but this interactive version allows you to scream at the painting and get a rise out of it. Ah! So we'll be working on that on the live stream tomorrow. Please tune in at 4 o'clock Eastern Time.
It's like not only are you watch the existential screen, but then you can be part of the existential angst. It's a very interactive, modern interface. And it takes less time than reading Twitter.
Next week, tune in for the Melting Clock Project by Dolly JP.
I can do that because I'm in Southern California. The Melting Clock Project.
You are melting.
All clocks are
now dying. All right, thanks, guys.
Erin.
Hi. So I'm building a really fun new project. I just joined my local makerspace and have a bunch of access to woodworking tools. So I have created a beautiful new tabletop. Can you guys hear me?
Yeah. We're just amazed by your
Okay,
beautiful
just checking.
tabletop.
All right, just checking. Okay, it's really pretty. It's resin and walnut, and I am putting some LEDs behind it so that when I put the whole thing together, it glows like a beautiful little lake. It has some animations running around. You can kind of see, so it looks like the water's just sort of swirling in there. This is my prototype project. I'm actually working on making a bigger one that's a kitchen table size. It's going to be really, really pretty. I'm very excited. Underneath, what you can see is it's got a neopixel strip and using a circuit playground right here. And then it's the secret to making it look so nice is it's mounted on a acrylic mirror. So that actually reflects the neopixels down into the mirror and then back up out of the LEDs or out of the top of the resin. And it's just, I mean, it's just stunning. So I'm very excited about this. I'm going to be making the big version and do a video of that and put that up in the learning system so that you can see the whole process of making the whole table. So that's what I'm working on this week. Very exciting.
Yay.
Right.
Woodworking and electronics. Okay, next up, welcome back, JMK.
Hey, so my microphone is somewhere. I don't know where.
You sound okay.
Yeah, so I'm using my webcam microphone, so it's not as good. So the first thing I'd like to show is on Prime Day, my dad got me this. It's Raspberry Pi. It's a car robot thing, and the first thing I noticed is it uses those same motors that got stock just before I left for camp.
Yeah.
And the second thing I noticed is probably the most annoying thing was that it uses these annoying batteries that fit in a AA case but are 3.7 volts. And the problem, after we bought them, it said that you could only use batteries without a protective circuit, which I thought was stupid, because if this thing accidentally uses an overcurrent, which it could because this circuitry is like not the best voltage circuitry, then it'll shut off everything and possibly cause damage to the SD card on the Pi, and then I have to rewrite it, which is a bit of a problem. And it has a cute little camera here, which I figured out was really just a webcam. So I plugged it into my computer, of course, and I tested it. And it runs Python, so that's cool. And the second thing that I've been recently working on is this new version of the JMKHost website. So if you look at the old one, it's basically just, after it loads, it's basically just a FTP site that I made look like an FTP site. It's really just like HTML. But the new one looks a lot nicer. It's got all the same apps. You just don't see them all here because most of those on the other screen were just non-updated versions of the others. And we've got JMKOS. So this is the main place where I host the download of JMKOS. The notepad, my games package, which is still in work. And I made it so the little bar down here has an animation, CSS 2-second animation when you go over it. And what I thought was cool is if you click JMK Secure Hardware, then it goes in, then there's like a website that I put in dark mode, and it has the inverted version, same version of the taskbar. So I thought that looked cool. And
cool.
Yeah, so these are just for a project that I'm gonna show maybe next week, which is like a security system. So that's a little spoiler. I've got a little notice here, and you can just go to jmkhost.com. So yeah, that's it. Oh, and also if you click on these, you get a little, not only do you get this, like thing where you can download it, of course, but you get this little thank you for downloading file instructions available at JMK.
Oh, that's nice. That's good user interface design.
Yeah, so what I did is I made this a minimum height, like 275 pixels, instead of setting the height. That's the first time using that. So yeah, that's it for this week.
Nice work, JMK.
Good work. While you were at camp, there's two things that we released that might be interesting for you to check out. One is we have CircuitPython for Raspberry Pi. So you can use CircuitPython inside of a Raspberry Pi, and then Moo 1.0 came out, and you can also run that on a Raspberry Pi. So theoretically, you can do everything on that robot, and you can write CircuitPython there and Python and Moo. So
I actually had a problem with the robot where I needed to FTP it, but then in the manual it said it would have like 192.168.0. something or other, but then it really had .0. I don't know, something else.
Linux.
I had to figure that out, and actually, since this doesn't let you, once you built it, you can't shove the port into the HDMI because there's a servo in the way. Yeah. So I had to go into my antivirus, do like a network scan, and then it showed the IP of something under Raspberry Pi Foundation. And that's how I FTP'd it, so that's good.
You hacked the robot. Good work.
Good work.
Okay. Next up, we're going to go to Bill, and then we'll go to Adam, and then we'll wrap up with CScott. All right.
Hey, Bill.
Hey, Bill.
Hey, guys. How are you?
All good. Yep.
Good. So I was actually just working. I wasn't planning on being on the show and tell, but I realized I was in a kind of a good spot to show an update on something. And also a thank you. Noah fixed one of my 3D printing boxes today, and it fits perfectly. So thank you. But I do want to show an update. We have, hope you guys can see this.
Yeah.
Yep. So long ago and far away, I asked you, Lamore, to make me one of these. This is actually a wing that has 5 relays on it. And we just got it back from PCBWay, and it's all assembled and done. And it works, and it works kind of great. It has an I2C port expander. It's got 2 relay drivers, 7-channel relay drivers, so that we can do the 10 latching coils for the latching relays. It also has one of the current sensors on here. And what this lets us do is there's actually a lot of projects that this lets us do pretty well. So if we want to be able to mimic a digital joystick, we've got left, right, up, down, and activate. And the big driver for this was a gentleman in Seattle named Jim Lubin, who wanted to be able to route what his sip and puff switches did, the change between 3 different devices. And so that's what I'm actually wiring up right here. It's got 2 input jacks over here are going to come in, and there's actually 6 output jacks on the other side. And because we use both sides of the relays, they're double pole, double throw relays, because we routed both sides of them, we can actually route through the positive negative of each switch and let his 2 switches switch between 3 different outputs. And the current sensor lets him do a long sip to switch between them. So I'm really happy with how this turned out. It's a wing. It works great. We had a flaw in the design. We had to adapt to it. This is how they came back from the fab house in China. They ran about $30 a piece with delivery, which we never could have made them for that. And the wiring would have been kind of insane. So we're really happy with this. It's kind of our first PCB that's come back and been assembled. I think it's awesome that we can do that now. So thank you, Lamore, for your tutorials. I didn't know how to do any of this a year ago, and I've learned from you. So that's
you're doing great. I mean, that's amazing. Congratulations on getting the projects that your community needs done. That's what we're here for. You know,
makers making makers.
That's open source. That's the dream. So I'm glad it,
I can't be much happier with how that's turned out. So thank you again. I will give an update when it's fully working. I'll show a demo at a future one of these, or I'll share a link when we actually see it working in Seattle. But thank you.
And just to verify, did you do the design in Fritzing or in EagleCAD or KiCad?
No, I did it all in Eagle. Again, from your videos, I actually did a video yesterday. I'll show you something you'll get a kick out of, I think. Oh, I can't. Yeah, I can. I can move it up here again. Same problem. Sorry. So I actually did a video yesterday for our group to try and teach some of our folks how to do basic EagleCAD. And so this is actually a switch isolator. It's got an input switch on one side, an output switch on the other, and a relay in the middle. Sometimes we have devices that you can't use an electronic switch. You need a physical switch to control, and this lets that happen. So I walked them through like the basics of how to do a through hole, design in Eagle, and it worked out great. We had people commenting on it. I think Noah was there yesterday, but a bunch of people were involved. And so, yeah, I'm really happy to. I don't know how to get this to stop screen sharing now.
Infinite.
We're gonna go to Adam anyways. Thank you so much.
Thanks, Bill.
Yep.
Right. Adam, and then CScott.
Hello.
Hey, Adam.
So once again, we've got this machine right here. Remember last week I spent a lot of time back here working on this bay. It turned out the problem wasn't just right here. So the responsibility of this unit right here is to give power to all the electromagnetic lenses inside the column on this thing. It turns out the reason that bay was taking damage so consistently was that the lens that was right in this section, condenser number 2 lens, had developed a short to ground. So that short to ground had taken a 90 volt 20 amp rail and sunk it down to 4.5 volt, that who knows how many amps through the coil, which understandably this is a very high precision, very large electromagnetic coil that all of a sudden got very, very hot and melts part of it. So it's not an easy part to get. There was exactly one person in the country who had one and he didn't want to sell it, which makes things interesting. But through a little bit of testing, I was able to determine that the coil actually wasn't too badly damaged. It was only in the outer layer of the coil. So I took the column apart quite a bit, which took about 3 or 4 days, and then just took the copper off of the coil to get to the outer layer, which the damage was within the outer layer, and that actually managed to fix it. So as I said, getting this coil is pretty interesting. You've got to pull out this whole aperture assembly. Then you have to lift this entire chamber up using these bars right here and this pneumatic lift. And then pull out a series of really, really high precision steel parts that are like machined to like 1/10 of a thousandth tolerance to get the magnetic field shape correctly. And then just start taking the coil apart. Ultimately, they repaired it though, so did that, replaced a whole bunch of resistors. And now I've got a working beam.
Yay.
So TEM is a bit different than SCM. SCM bounces electrons off the sample, and TEM, I've got my sample in the middle right here, and I'm shining the beam from the top of the column through down to the bottom of the column. So that's my screen. And you can see I can do a lot of manipulation to the beam. I can zoom on my sample. Bring my brightness. This control right here, this kind of brightness, the spot control, that's the coil that died, and it's pretty fundamental to how the machine works, so you can't really use it without it. But other than that, the machine is doing pretty well. It's looking pretty cool. It's got those same like 70s, 80s lighting style that my SCM at home does. It's actually the same manufacturer as my SCM. But it's capable of a lot higher resolution. I don't have the beam fully aligned yet because I just got the thing back online this morning for the first time, and there's a lot of systems you got to get going. It's going to take me probably about a day, day and a half to build a power supply up to its maximum voltage. It runs at 120 kV, and I've only got it at 40 kV right now, so I got quite a ways to go to get that thing up to full operation spec. But I got some other cool things like the diffraction mode working. This is shining the beam of electrons through the sample and then watching how the electrons diffract. And those rings you can see, not very clear on camera, those rings you can see are created by the gold layer that's on the sample diffracting the electrons onto this ring. You can measure those rings and determine the lattice spacing of each time it starts to the gold. So that's just kind of one of the things microscope does. And the other thing I'm working on now is spectrometer.
Okay, and you're starting to cut off a little bit, Adam. Okay. So I don't know if you can still hear us, but I think we're gonna move on to CScott anyway. Yeah, your audio. Yeah, your audio just started coming out. Sorry about that.
No problem.
Okay. Did you get a chance to show us everything?
I can show you one more thing real quick, but
yeah, your audio is back now. If you make it super quick.
Oh, okay. Yep. So this thing right here, this is a spectrometer or an X-ray spectrometer, and this allows the machine to actually look at samples and then give us back this X-ray spectrum. So this is the X-ray spectrum of the gold that's in the machine right now. So once I get this thing fully calibrated, this machine will be ready to put all the way into service.
Yay!
All right. Well, you get whatever type of sticker you want as usual. Good work. Okay. CScott, play us out.
Hey guys, just a quick check-in to talk about the M4 Feather and what I'm up to. I'm trying to save a little bit of prototyping time because a few years back I built this thing. This is an 8-channel MIDI to CV unit that I built for my 5U height modular. It didn't work quite right, and I've revised the board since, and I haven't built it yet, but this is still good enough for me to test the proof of concept that I'm trying to work on with CircuitPython in the M4 and the M0, but I think the M4 have an easier time of it. Is I'm trying to get away with time division multiplexing without relying on an interrupt-driven timer callback. At some point, I'd hope to figure out how to do that, but I think that CircuitPython runs quickly enough. Things that I was doing in like Z8 or Z80 code 30 years ago are still slower than what I'm getting here, and I was able to make it work then. So I should, in theory, be able to get it to work here without any special tricks. Yeah, the idea here is, I'll have to show you the schematic another time, but this board has, it's one DAC, but it's split into 8 channels by using a demultiplexer and track and hold amplifiers to remember the voltages for each channel. But you have to refresh them relatively quickly within like 1 or 2 milliseconds, or they start to droop, and that droop can be heard as a pitch change. It worked well enough when I tried this. This was originally done on an Arduino Nano, and the main problem with the board is I use too cheap an op amp. I need to use a better one, and to use a better one, I have put a bipolar power supply on it. But anyway, back to the CircuitPython bit. I'm going to just try directly updating the time division multiplex stuff without waiting for time slices. I'm going to like try and extract a millisecond from the monotonic time and see if it will give me what I want. And I'll report back on that when I've managed to do something.
Okay. All right. It's an update.
Outstanding. All right, well, that's show and tell this week. Thank you, everybody. That's
Thank
our
you,
favorite
everybody.
half an hour every single week. We're here at 7:30 p.m. Eastern Time every Wednesday. And we'll get some tunes and some screams.
Yeah, that's it.
The existential dread of being a replicant, not knowing how long I have to live.
Okay, we'll see everyone asking engineer.
You guys.
Just a few minutes. Bye-bye, everybody.
Bye, everybody.